Okay, this is the paper that was done in June, July 2022. This is Engineering Mathematics 3. Now we have question 7. Question 7a, which says that determine a half-range Fourier cosine series of the function. This is the function. F of t equals to t squared minus pi t in the range t is greater than 0 but t is less than pi. And then from 1 to 2 they are saying that by setting t equals to 0, we are required to show that pi squared over 6 is given by the summation of 1 all over n squared. Solution. Now they are saying that we determine a half-range Fourier cosine series. Now when they talk of a half-range cosine series, it means that Pn is equals to 0, so that our series therefore shall be so that will be our series. Because this is 0, so we shall only be required to get a naught and an. So once we get a naught and an, we come and insert them in that formula, and then we will have coded the half range for a series for the given information. Now we can start by getting a naught. A naught is given by 2 all over pi. We are integrating from 0 to pi. Our function is t squared minus like that. So we integrate this. So when you integrate t squared, you get t cubed all over 3 minus, when you integrate pi t, you get pi t squared all over 2. And of course, we have the upper limit, which is pi over 0. We now insert in the given limits. So this will be equal to 2 all over pi into, so this will be, where there is t, we put there pi, so it will be pi cubed all over 3 minus, now this will be pi dot pi squared all over 2 minus, where there is t, we now put the lower limit. So you can see when you put there 0 and 0, so everything will be 0 there, like that. So this equals to 2 all over pi into, now this will be pi all over 3 minus all over 2. Now pi cubed all over 3 minus pi cubed all over 2, we remain with, so this will be minus pi cubed all over 6. All over 6. Now these two will cancel, there 1, 2 here 3. This pi goes with 1 pi there, so we remain with our a naught equals to minus pi squared all over 3. That is our a naught. Write it here. Okay, that is it. So the most important thing is for you to be able to understand that a naught is given by 2 all over pi. Then we are integrating from 0 to pi. We've been given there. Then you integrate this. Then you navigate it through. So we shall be able to get a naught as negative pi squared all over 3. Now we go to the next constant, which is an is given by 2 all over pi. We are integrating from 0 to pi. Then we have t squared minus pi t, then cos n t dt. Now here we shall integrate by parts. This will be our u, this will be our dv. Now integration by parts formula is given by uv minus the integral of v du. That is the formula. Now we are saying that u equals to t squared minus pi t. So we differentiate u with respect to t. So we have du dt equals to 2t minus pi. And then we are saying that dv equals to cos nt. Now to get the value of v, we integrate this equation on both sides. When you integrate dv, you get v. And then when you integrate cos t, you get sine nt over n. Be able to get that. So this is our v, and then this is our v is given by that, and then du dt is given by that. So here you can say that now du equals to 2t minus pi dt. Now we come back and substitute in this formula. So we are saying our an will be equal to, now we maintain our 2 over pi into uv. Our u is now t squared minus pi t. Then our v is sine nt over n. Then of course we remember the limits 0 to pi minus this sign minus the integral from 0 to pi. But what do we have? Our v is now, this is our v, so we shall have that is our v. Then du is this one. So du is so that is it. So our an is now given by that. Can now rearrange the equation. Let me wrap here. So our an would be equal to 2 over pi into, I can write that as 1 over n into t squared minus pi t sine, like that. And then I have minus, you have now minus. Now here you take out 1 all over n, the integral of from 0 to pi. So I remain inside with the sine nt, grab here, sine nt, then 2t minus pi dt, like that. So again, we integrate these by parts. So this will be our u, this will be our u, and then this one will be our dv. Now, when you, so we have dv equals to sine nt. So when to get the value of v here, we integrate on both sides of this equation. Therefore, v will be equal to, when you integrate sine t, you get minus cos nt all over n. And then here u equals to 2t minus pi. So you differentiate u with respect to t, you'll be able to get, therefore du dt will be equal to 2, meaning du equals to 2 dt. Now, as we have the value of v, we have the value of du, we have u, we now insert them in the integration by parts formula. Therefore, if I can rewrite all of this, so I'll say that our an will be equal to 2 all over pi into t squared minus pi t sine nt. Of course, we have the limits. Then minus 1 over n, this n, and then you open the bracket, because here we are again integrating by parts. So, and integration by parts formula is uv minus integral v du. So here we need to identify what is our u. Our u is 2t. So we have 2t minus pi. Then what is our v? Our v here is minus cos nt all over n. So I can start with that negative here, so that I write cos nt all over n. Then you remember the limits, pi 0, then minus, you maintain this sign, the integral from 0 to pi, and then our v, which is now minus cos nt all over n, then our du equals to 2t dot 2d, like that. Now wrap this one again. So can now write the equation again. So we have 2 all over pi into 1 all over n into t squared minus pi t sine nt minus 1 all over n into, now this one I can write it as minus 1 all over n. I take this 1 all over n, so that I have 2t minus pi cos nt, then the limits. Then here, with this negative and negative, it will be positive, so it will be plus. Then we take out 2 over n, because it's a constant. then you will remain with cos like that. Now this will be equal to, of course, the an 2 over pi into 1 over n t squared minus pi t sine nt minus 1 over n minus 1 over n 2t minus pi cos nt. Then when you differentiate cos nt, you get, so it will be plus 2 over n. When you integrate cos nt, you get sine. You get sine nt all over n. So we can rearrange this one again. Sine minus cos nt plus, you can take out 1 over n so that we have 2 over n squared into sine nt. Now when we now substitute in the limits, because this is sine, when we substitute in the limits, this will turn to be 0, and also this will be 0, so that we remain with an equals to 2 over pi. So here we have minus, and the minus will be positive, so we remain there with 1 over n squared into 2t minus pi cos nt like that. Can take 1 over n squared outside. Two t minus pi cos nt like that. Now we substitute in the limits. So when there is 2, put their pi, so we have 2 pi minus pi cos n pi minus, now substitute the lower limits. It will be 0 minus pi cos 0 times n, we have cos 0. This equals to 2 over pi n squared into 2 pi minus pi will remain with pi cos n pi minus and minus it will be plus pi because cos 0 is 1. 1 times pi we have negative pi. With this negative becomes a positive. You can factorize out pi so that this equals to 2 pi over pi n squared into cos n pi plus 1. This pi and that will cancel, so that we have 2 over n squared into cos n pi plus 1. Now at this point we can consider when n is odd, we use 1. So we can say that n equals to 2 over n squared into, now when n is 1, so we get cos pi plus 1, which is equals to, cos pi is the same as cos 180. Cos 180 equals to negative 1. Therefore, this is 2 over n squared, negative 1 plus 1. 0 times that equals to 0. So we are saying that an equals to 0 when n is odd. When n is odd. And then we can consider when n is even, our an will be equal to 2 over n squared into, we use 2, number 2. So you take 2 times pi, so it's like we are getting cos 360. Cos 360 is what? Is 1. So 1 plus 1 is 2. You have 2, which equals to 4 over n squared. So what does this mean? It means that the series only exists with even numbers. At odd numbers, there's no series, but at even numbers, the series is 4 over n squared. So we are saying that our an equals to 4 over n squared and n even. So what will be the series then? Our f of t now will be equal to, we now substitute our a naught is negative 3 negative pi squared all over 3. So we have a half times negative pi squared all over 3, then plus our an is 4 over n squared. Now it will be into cos. Remember the series exists with even numbers, so it will be cos. Now when n is 2, it will be 2t plus cos 4t plus cos 6t plus cos 8t, etc. with even numbers only. So this and that, so this will be minus pi squared all over 6 plus 4. Now we can take n inside so that we have 4 into, now n, so here we have 1, 2 squared, so we have 1 over 2 squared cos 2t plus, so it will be 1 over 4 squared cos 40 plus 1 over 6 squared cos 60 plus 1 over 8 squared cos 80. It continues like that. So this is the Fourier series. And then they were saying that Roman 2, that when we let t equals to 0, we show that pi squared all over 6 is given by that. Let us see. Roman 2, so this would be 0 equals to now minus pi squared all over 6 plus 4 into 1 over 2 squared. Now t is 0, cos 0 is 1. So cos 0, this is 1. 1 times that will remain that plus 1 over 4 squared plus 1 over 6 squared plus 1 over 8 squared. It continues like that. Remember, this is 0, cos 0 is 1. So that's what we have. So this equals to negative pi squared all over 6 plus into what is this? So we have, this is 4 this will be 4 over 4 plus, we are multiplying through pi 4, so we have 4 over, this will be 16 plus 4 over 36 plus 4 over 64, and then it continues like that. Now this will be equal to minus pi squared all over 6 plus, so here we have 1 plus, this is 1 all over 4 plus 1 all over 4 here, 1, 4 here, 4 there, 1, 4 there, 4 here is 9 plus 4 there, 1, 4 there, 4 into 64, 16. It continues like that. So this is the same as when this comes on this side, it will be pi squared all over 6 equal to, now we have 1 plus 1 over 4 plus 1 over 9 plus 1 over 16. And then we can rewrite this one as we want to use that this is given by, so pi squared over 6 is given by the summation of n equals to 1, then 1 over n squared. We have shown, because if you want to get this one, when n is 2, when n is 2, then you have so when n is 1, you have 1. So when n is 1, it will be 1 over 1 squared, which is 1. When n is 2, it will be 1 over 4. When n is 3, it will be 1 over 3 squared. When n is 4, it will be 1 over 4 squared, which is 1 over 16. So we have shown that pi squared all over 6 equals 2 to the summation of 1 over n squared, starting from n is 1 up to positive infinity. Thank you for watching and listening.